Students, welcome to SOPS's classes. Today we'll be solving the CSIR UGC NET questions from the June 2018 paper. We'll be solving the set C, which is the set C of the mathematical sciences paper. So let's start off with question number 84. In question number 84, it has been said that which of the following statements are true. Option 1, if sequence of ak is bounded, then summation 0 to infinity ak into z to the power k defines an analytic function on the open unit disk. Option 2 is that if summation of 0 to infinity ak into z to the power k defines an analytic function on the open unit disk, then the sequence ak must converge to 0. This is the second option. Now the third option is that if fz is equal to summation 0 to infinity ak into z to the power k and gz is equal to summation of 0 to infinity bk into z to the power k, which are two power series functions whose radii of convergence are 1, then the product f dot j has a power series representation of the form summation 0 to infinity ck into z to the power k on the open unit disk. This is what we know. And let us go to option 4. In option 4 is that if fz is equal to summation 0 to infinity ak into z to the power k has a radius of convergence 1, then f is continuous on omega where z belongs to c and mod of z is less than equal to 1. So these are the four options that we have been given, and we need to check out the truthfulness of these statements. So now in the first option it has been given that ak is bounded. So if ak is bounded, then we can take some value, or we can take the supremum of ak as some value, suppose p, say. So that implies that summation of 0 to infinity mod of a to the power k into z to the power k is always less than p into summation of 0 to infinity z to the power k. We can write it like this. Now this is equal to, let us take this is equal to some value m. Okay, this is equal to some value m. So therefore we can definitely say that therefore the summation 0 to infinity ak into z to the power k converges absolutely. So now if it converges absolutely, that means that it converges ordinarily also, means it converges ऐसे भी converge करता है, it converges on its own. So if it converges, then we can definitely say that also we know that limit of a convergent power series, as we know this is a power series and it is also convergent. So limit of a convergent power series is an analytic function, So as it has been already said that if the sequence is bounded, and we have already assumed that it is bounded, and we have assumed that the supremum of ak is equal to p, suppose, then we have defined that the limit of this, then ak z to the power k will define an analytic function on the open unit disk. So this implies that option 1 is correct. Now let us shift our focus to option 2. In option 2 it has been said that if summation 0 to infinity ak into z to the power k defines an analytic function on the open unit disk, then ak must converge to 0. Now for option 2, what we'll try to do is that we'll take, let ak be equal to 1 for all k. So if ak is equal to 1, then that implies the summation 0 to infinity ak into z to the power k will become summation 0 to infinity z to the power k. And we know that summation of 0 to infinity z to the power k converges to mod of z, which is less than equal to 1. And we can definitely then say that it does not converge to 0. So this is the statement that implies that option 2 is false. Now let us shift our focus to option 3. In option 3 it has been said that if fz is equal to summation 0 to infinity ak into z to the power k and gz is equal to summation 0 to infinity bk into zk, and these are two power series whose radius of convergence are 1. Then the product f dot g has a power series representation of the form 0 to infinity ck into z to the power k on the open unit disk. So let's proceed with this question. So therefore we can definitely say that we have already found out that these kind of functions are analytic, that both fn if f is a power series function of this format, then f is analytic. So therefore let's proceed with option 3. Now in option 3 we know that f and g are analytic on z, are analytic basically on mod of z is less than equal to 1. We've already found out is less than 1. So if this is the case, then that implies that in this interval fg is also analytic on mod z less than 1. So if fz is also analytic on this format, then we can write that fg can be of the power series form, and we can take this as summation 0 to infinity ck into z to the power k. It can be of this format. So therefore option 3 is also correct. Now let us shift our focus to option 4. In option 4 it has been said that if fz, which is equal to 0 to infinity ak into z to the power k, has a radius of convergence 1, then f is continuous on omega where z belongs to c and mod of z is less than equal to 1. So we can take an example of such a format is that option 4. So we have been told that omega belongs to z, that omega is such that z belongs to c where mod of z is less than equal to 1. So we can take a function f of z which is of the format 1 by 1 minus z of this format. As you can see here, radius, it is a power series basically. Here this is a power series and its radius of convergence is equal to 1. Now if this radius of convergence is equal to 1, but you can see that at z equal to 1 f of z is not continuous. So the statement that says that if fz is of a power series format and it has a convergence radius of convergence 1, then f is continuous on this very interval, this is wrong. Okay, so you can see that this is a power series which is radius of convergence is 1, and but at z equal to 1, as stated by this set, at z equal to 1 f of z is not convergent. So therefore option 4 is incorrect. So the correct options are, let me go back to the correct options are: option 1 is correct, option 2 which says that k will converge to 0, this is not correct. Option 3 which says that power series representation will be of the form ck into z to the power k, this is very much correct. And option 4 which says that f is continuous on this very interval, on this very set, this is also wrong. So the correct options are option 1 and option 3. 1 and 3 are the correct options. So today we have solved question number 84 from the UGC NET CSIR NET exam. We will be solving the next questions in the subsequent videos. Till then, keep watching Solve Classes videos for more solutions and content. Thank you very much.